Hello and welcome back to the Computational Social Science podcast. My name is Dino Carpentras, and today we will talk about one of my favorite topics, which is the topic of collective intelligence. So, what we will do today is that we will approach this topic both from a more scientific point of view, but today I want also to explore this idea of collective intelligence a bit also from the perspective of everyday life. And we can see how this will impact, eventually, some of the conversations that we might have sometimes. Mainly because I see a lot of rhetorics in, the media, just online, about the fact that some way humans are stupid while nature is smart and good. So again, this is not going to be a really scientific discussion, it's going to be just a tiny digression on this topic. But don't worry, the main point of today's conversation is still going to be about collective intelligence from a more scientific perspective. What we could do here is to look at the definitions. But what I notice is that there are many different definitions of collective intelligence, and some are very restrictive, some are very general, some will include some effects but exclude some other effects. So what I'm gonna do for today is that I'm gonna leave it very loose. Again, this is not a scientific review, so we can do these kind of things, and we will intend collective intelligence as just the fact that sometimes we can bring people together, and when people coordinate together, they might become smarter and smarter. Of course, I don't mean that they become individually smarter, but that as a team, as a group, they are smarter than individually. And I know this might be almost trivial to many people, because some people might say well, of course, if you have more people, they are going to be smarter. Two heads are better than one. There is even an expression about this. But at the same time, there are many other cases where we observe that by putting people together, actually people become more stupid. And indeed, there is even a term for this, which is collective stupidity. Of course, this is not so much discussed in the literature as well as collective intelligence, but we can observe several cases of people working together and producing way lower quality than individually. So one of the big questions of today also is going to be, what is setting them apart? What will determine cases in which we have collective intelligence and cases instead where we have collective stupidity? And what can we do to have more collective intelligence and less collective stupidity? So, in the second part of this podcast of today, we will discuss definitely about this, what are the different factors. But in the first part, I actually want to give you several examples. Some are going to be fascinating, some are going to be kind of funny, and some other might also make you very disappointed with the human race. So let's start with what is probably the most famous case of collective intelligence. And this was documented by Francis Galton in his paper Vox Populi. What happened here was that Galton was at a fair, and there was a competition in which people had to guess the weight of an animal, an ox to be specific. And what Galton noticed was that, of course, people were trying to guess with all possible numbers, so most people were very off. But by taking all these values, all these weights, and averaging them, he obtained a number which was extremely close to the real weight of the ox. And this tells us two things. The first one, which you might notice, is that as scientists, we cannot enjoy anything. We go in mundane events which are supposed to be funny, and instead we keep thinking about working. And, probably you can relate to this. But the other important thing is definitely that it was a very well documented way to show that we can take the work of multiple people, combine it some way, and produce a result which is way better than what those individual people would have done. And indeed, there have been a lot of studies which showed how we can take, the guess of multiple people, average out, and get very good results. Now, something that may have unlocked some way a new level of collective intelligence is the advent of the internet. And indeed, we have a lot of documented cases of very fascinating types of behavior. Probably we have, with Wikipedia and GitHub, we have massive collaborations. With Wikipedia, people were able to build the biggest encyclopedia in the world. And there are several studies which show that actually the quality of Wikipedia is comparable with many other general encyclopedias. However, at the same time, we also have many cases where people some way promote on the internet very bad behavior. So, for example, we have the cascade of fake news, where we take something false and we keep repeating it, and this gets spread over and it reaches millions of people. And this is interesting because these are kind of polar opposite examples. Because on Wikipedia, we have that people are able to some way distill the truth, or some way get to very high quality understanding of reality, of information. And on the other case, we have that people spread false information. So again, we have both collective intelligence and collective stupidity. But when I was looking at all of this, I was half impressed and maybe not so impressed at the same time. Because yes, these are cases of collective intelligence, but getting to something that is true, I don't know if you can consider this really intelligence. To me, intelligence is something more related to problem solving. But what is interesting is that we have several documented cases of people performing problem solving collectively. And there are a lot of documented cases. Here I just want to mention very quickly a very good example, which is Bellingcat, which is a collective of people doing open source intelligence. So they try to solve cases by getting information online. And probably the most famous case of open source intelligence is something which, is not connected to Bellingcat, but is connected more with 4chan and trolls on the internet. And this is the case of Shia LaBeouf and some way the so-called catch the flag competition. Now, let me give you some context here. So what happened was that after the first election of Donald Trump, Shia LaBeouf, which was already famous online for doing some very weird things, and so it was already the aim of multiple trolls online. But anyway, I was saying, Shia LaBeouf decided to start a campaign against Donald Trump. And during this campaign, people decided to troll again Shia LaBeouf, sometimes for political reasons, sometimes just because they like to harass Shia LaBeouf because they found it funny. You can decide if this is ethical, unethical, probably not too much on the ethical side, definitely. But this is why we will say this is something which I think combines together collective intelligence and collective stupidity. So what happened was that at a certain point, Shia LaBeouf got very tired of being harassed. Also, there was several arrests because people were fighting, I guess, at a certain point, and even Shia LaBeouf got arrested himself. So anyway, he got tired of all of this, And he decided to continue his protest some way, putting a flag in the middle of nowhere in such a way that nobody could identify where the flag was. And he put this flag and he put a camera tracking the flag, but the camera was on the ground. So the only thing that people were able to see was the flag and the sky. In this way, he thought nobody would keep harassing what he was doing, and his campaign would continue to live on. However, what he didn't realize was that he just started the biggest catch the flag competition ever made. Indeed, what happened at this point was that a lot of people online, maybe for political reason, maybe because they like trolling or just because they liked the challenge, they decided that they needed to find the flag. And they start using all the informations that were available only from this camera. And you might think like, well, there is not much information because you can only see the sky. But people on the internet started using every possible information, such as the position of the stars during the night, the direction of the winds, the weather conditions, the flights that they were able to see, so if different airplanes were passing at different time, and many other informations that allowed them to get closer and closer and closer, and at a certain point they even used the audio of the camera because they were able to understand pretty much the region, but they didn't know exactly where the flag was. So they started going around with their cars and honking in such a way that the camera would pick up the sound of the car, and in this way they were able to get closer and closer and at the end find the flag and steal the flag. Again, is this collective intelligence or is this collective stupidity? Well, you might choose. Definitely, I would say is not so much on the ethical side, but also it shows the ability of people online to coordinate together and do some crazy problem solving. And again, I'm reporting the case of Shia LaBeouf mostly because it's the most famous one, but definitely check out also Bellingcat because I think they do some amazing work and, at least it's not aimed at trolling, at harassing people. Anyway, all of this actually opened the door for an interesting question. And the question is the following. Can a group of non-experts be as good as the experts? Some way, can we get rid of the experts? Not that we have to get rid of them, but can everyday people replace experts? And some way this question was asked also by NASA in a series of projects that they organized in which they took a lot of different pictures that needed to be measured and classified. And unfortunately, their experts didn't have enough time to go through all the images. So what they did was that they outsourced many of these images, for example, classifying craters, and they give it to everyday people online and say like, now you classify the craters. And they develop different ways to train people to identify how to merge multiple information. For example, the same crater would be classified by multiple people and they needed to develop some way to bring this information together. But what they noticed is that by using this method, they were able to classify many more images and the quality of the results was actually very high, was comparable in many cases with the one of the experts. And there is a very interesting paper that I will put in the show notes, which actually argues that in some cases, so this paper is not connected with NASA, is a completely different paper, but is arguing that in some cases, non-experts can even outperform experts. Now, this podcast is all about complexity, and so I want to give a little more of details on this paper, and I want to say that this paper is based all on simulations and mathematical modeling. I'm not aware of any replication of this paper in the empirical case, so some cases in which we really see that non-experts are better than experts, but I think it's still a very interesting paper, and I want to quickly explain to you when this can happen, when non-experts can outperform experts. So imagine the following. You have a problem which has both some way to be optimized, but actually the best way to solve it would be just exploring as much as possible. For example, imagine we have a terrain, and we notice that the more we go to higher points of the terrain, the more likely we are to find, I don't know, some gold underground or something like some prize. So the taller the point where we stand, the better chance we have to finding good reward. So in this case, what the experts would do is that they will go to the top point, the highest point of the map, and dig there. So what is interesting is that if you have 1 or 100 experts, they will all tend to do the same thing. They will try to solve the problem in the same way. And so they will converge pretty much to the same direction. However, if you have non-experts, what non-experts will do is that they will try to explore the map because they don't have the same strategy. So everybody will try to solve the problem in a different way. So some people will dig in one place, some people will dig in another place. And in this case, actually, they can explore much more. And if the problem is such that actually by exploring more, you have more probability of getting good results, then in this case, non-experts, will cover much more ground. And so they will have much higher probability of finding better results than experts. I hope the example was clear enough. It's kind of complex to explain, and also the paper is very math heavy and simulation heavy, but if you want to read it out, it's very, very interesting. Now, before actually jumping in and discussing what is causing collective intelligence or collective stupidity, I want to spend just one moment to remember the fact that collective intelligence is not just something that happens with humans. We think that in order to have collective intelligence, you need to have a very intelligent brain. But actually, we see this also in the animal kingdom. And indeed, ants and bees are very famous for forming collective intelligence. Ants can do some amazing things. For example, they can create bridges with their own body, they can find food, they can coordinate a lot of different things all together. So they really rely on collective intelligence. At the same time, ants are also famous for collective stupidity. Indeed, one of the main things that happens with ants is that in order to find food and just find the track where they need to go, they leave some signals, some markers on the ground. And in this way, they just follow the trail generated by other ants. But unfortunately, what might happen is that sometimes this trail can be destroyed because, wind or maybe some animal is passing by and some way it destroys the trail. So the ants need to rebuild the trail in some way. And unfortunately, what might happen is that instead of finding the continuation of the trail, they actually loop and generate a circle. So they start moving in a circle because they think that that's the direction where they have to go, and they keep going and going and going until they actually run out of energy and die. So I would say this is a clear case of collective stupidity, not with humans, but in the animal kingdom. And there is another fascinating article that, again, I will put in the show notes. By the way, with this paper, I'm really moving beyond my field of expertise, but I'm gonna talk about it anyway. I really hope I don't say anything stupid here. But this paper really argues about the fact that collective intelligence doesn't even require a multitude of living beings, but it is kind of a multi-scale effect or system in all nature. Now, let me give you an example about this. So, if you think about your body is composed of a series of organs and systems that they all work together to solve problems. Because actually what your body is doing is trying to keep you alive. You start running, your heart starts pumping more blood. You cut yourself, they figure out some way to stop the bleeding, etc. Like your body is kind of a collective system of components that need to work together in order to solve problems. And if you keep zooming in, actually you can find that the cell, for example, is also composed of many different components. And these components interact in a smart way to solve different functional problems. For example, for keeping the cell alive or doing other functions that the cell needs to do. So what this paper is arguing is that in order to create collective intelligence, you do not even need a brain. You just need some components that interact in some kind of a smart way to actually solve some kind of problems. And I want to use the perspective from this paper to think for a moment about what, many times you might hear on the media or, in conversations with your uncle or whatever. And is this idea that, humans are some way stupid and nature is smart, nature has everything figured out, humans not. Well, first of all, nature some way is smarter than what I realize, at least. And by the way, this is just my perspective. This is not scientific at all. It's just like a small tangent. But this paper made me realize really how smart nature is. And at the same time, I think also humans are very, very smart because, if you think about it, we are actually coming from the same environment. We are animals as well. And so all the properties of nature, all this collective intelligence that exists at so many levels is also a properties of humans. And unfortunately, collective intelligence sometimes tries to get some shortcuts, it doesn't work, and then we end up with collective stupidity. But, this is something that we are trying to figure out. We try some things, we see if we get better. If we get worse, actually we try a different way. And we try getting better and better. At least, this is my perspective. I don't know if it's going to be useful or, maybe it lights your day or maybe it's just complete garbage. You choose whatever you want to do with this. Now what we can do is that actually we can get into the most interesting thing, which is like, what sets apart collective intelligence to collective stupidity? Like, what can we do in order to make humanity more intelligent instead of being more stupid? And here, the literature is very wild and scattered. So I'm trying to summarize a lot of different results. And what I've noticed is that there are mainly three components that we need to consider when we're thinking about a collective intelligence system. The first one is about the individual characteristics. Who are the components, or what are the components, that compose your system? Which characteristics do they have? So for example, if we are talking about humans, what are the characteristics of your group? Who are the people that compose your group? because as you can imagine, this might change a lot the results. The second important aspect is the interaction and the aggregation. So once you have these people, so let's stick just with people for simplicity. Once you have this group of people, what do? Do you let them talk naturally? Do you let them do something separately and then you aggregate the result? What do? And as we will see, this is equally important. And this is another fundamental aspect to understand, because maybe you can have the right people, but if you don't use the right interaction system or aggregation system, then you can have terrible results. And last but not the least is the type of problem. What is the type of problem that we are trying to solve? In the examples we saw before, we saw examples of just trying to guess a number or trying to solve a deeply complicated problem. So these are very different tasks. And as we will see in a moment, depending on what you are trying to solve, you will try to identify different people and different type of interactions. So then let's start with the individual characteristics. And here, there are many different studies, but a lot of studies have been exploring how is diversity going to impact collective intelligence. Is diversity good? Is diversity bad? And well, most of the studies tells us that diversity is very good. Even if I would put a small caveat here, because diversity is extremely good for the exploration of the space. So, as you can imagine, if you have many diverse people with different backgrounds, ideas, mental characteristics, etc., every person will try to solve the problem from a different angle. And for many problems, this would mean that we will explore much more of the space and we can find better solutions. However, diversity also has a big problem, as we will see later, which is when we need to merge the results. Because if by any chance we need people to agree on something, as you can easily understand, the more diverse people are, the more complex it is to have them to agree on something, because everybody then will have different preferences or different perspectives on what they like, what they want to achieve, what they consider important, etc. As I mentioned before, the second important aspect is the interaction and aggregation method. In this case, there are different possibilities, but people have been exploring a lot this idea, mainly from Galton, of just averaging or some way combining multiple votes to see what is the most common response. And by the way, you can see this in a lot of shows on TV where somebody needs to guess the right answer, and what they can do sometimes is that they can ask the audience to find the right answer. And this is pretty much using the same collective intelligence as the one studied from Galton. You just have a group of people, and the group of people, on average, will tend to find the right answer. So this is definitely one method, but in more complex scenarios, what people do is that they rely on deliberation. This would be open discussion between people. And as we will see, this is kind of a game changer, because in this case, you need to take into account many other effects. For example, when people are discussing, many times there is an order of who speaks first. And this can generate quite a lot of biases, because the first person to speak will kind of set the bar for everything that comes after. And there are several studies that shows that if people don't explore the different solutions by themselves, when they are thrown in the deliberation phase, they tend to just stick with the first good idea that they can find. So there are many studies that show that actually it is better for people to have a first exploration by themselves and then start discussing, because in this way they will bring many different perspectives. There are also many other ways in which people can interact, and I will tell you my favorite, which is remixing. And unfortunately, remixing is still not very famous in research, and I really hope this will change, because I think it's an amazing way of interaction and also has a lot of potential for collective intelligence. Remixing is based on the idea that you can take something that somebody else has already done. The classic remixing actually would be you take a song from someone, you take pieces of this song, and you create a new song. But there are so many other ways in which you can do remixing, because you can take, the idea of a person and you can change it and make it a new idea. And, this is also, just for you to think, this is, for example, how GitHub works, but maybe even more important to us is how the entire scientific community works. Because we do not work in vacuum. We always start from what other people have done. We read papers, we take inspiration from them, we combine some of these results, we add something new, so we remix those papers and we make something new out of it. And we keep growing and growing and growing. So I'm really pitching remixing. If you don't know about it, if you can tell, I'm very passionate about it. Finally, let's talk about the different problems that we can try to solve. And as we mentioned before, there are some problems which are kind of guessing the right answer, or at some way identifying the right value of something. But there are also cases in which you need to solve a much bigger problem, like, finding the flag of Shia LaBeouf, or maybe doing something more useful with your life. But definitely there are so many different problems that require some kind of creative solution. Finally, there is also the case in which the solution is not uniquely identified, but is actually based on preferences. And you can imagine, if we need to find an agreement between different people, this is still some kind of problem solving, but it's a different problem solving, because I can think that we found a solution, but you might disagree on this. So this is a kind of combination of, let's say, classical problem solving and some kind of social interaction, which also it has not really been explored in the literature. Most of the cases of collective intelligence have been documented mostly for cases where we can find a clear solution. And I think this is one of the cases where we do this kind of things because they're much easier to actually measure. So now that we have all this information, we see these three different factors, can we identify what is generating collective intelligence and what is generating instead collective stupidity? Well, the short answer is no, we still don't know, unfortunately. But we already have explored quite a lot of different aspects. There are many other that still need to be explored. But unfortunately, we do not have a general approach to collective intelligence that says if you want to have collective intelligence, just do X, Y, and Z. Mainly depends by case to case, and we need to consider how these three different factors combine and work together to produce eventually one or the other effects. But some of the things that people have noticed is that especially if we're trying to solve problems which have a clear answer, this is just, classical problem solving or cases in which we have to guess the right value, it is good usually to have an initial phase where people explore independently, they come up with their own idea, and then they can bring all these ideas together. But again, a lot of this completely ignores more complex interactions like remixing. And I think in remixing, the interactions are so much important, because actually the fact that somebody has found a piece of information allows you to use that piece of information to create a new idea. And I think this is still kind of underdeveloped in the literature. Before concluding this episode, I want to discuss for a moment one of the, most long-term goals that we can have with collective intelligence. And, if we collect all the information that we had so far, that we discussed today, we have the fact that potentially we can solve a lot of problems by using a combination of experts and non-experts. And this eventually can tell us that, the way we have democracy at the moment could be changed. We could try eventually to have a completely horizontal system. Now, I'm saying that this will happen tomorrow? Definitely not. Will this happen in the long future? I don't know, maybe. We can explore and see if this is feasible or not, but we have some pieces of evidence to think of eventually having a completely horizontal systems which doesn't require representatives. And we all know that representatives can have all sorts of bad incentives because, political representatives, sometimes they need to, collect attention. They need to do some strategies in order to gain the support of some people. So, they might generate some pressure on the population and eventually divide the population. So what we could have instead is a system which of course needs to be designed in such a way that people are interacting in a way that brings collective intelligence instead of collective stupidity. So we would need to design the system very thoroughly, but eventually we could have a system where people identify their own problems and then they rely on, collective intelligence to find solutions to these problems. It is technically possible. It is definitely not practically possible at the moment, but we will see in the future if we will ever get close to this dream of mine. So I hope this episode was inspiring or at least maybe interesting. I don't know. I really hope I was able to achieve something with this episode. So if you're interested, check out other episodes. I will try to post more regularly. So if you have any questions or there is anything that you would like me to discuss in next episodes, feel free to reach me out on social media. I'm always happy to respond. Sometimes I might take a very long time to do that because, as everybody else, I have deadlines. This is not my main job. My main job is being a researcher, so that has the priority. But definitely, I'm happy to reply. So with all that said, have a wonderful day and be well.